All right, welcome to our explainer on one of the most, and I mean most, essential skills in the digital world today, SQL. You might not see it, but it's the hidden language running pretty much everything, from your social media feed to huge business decisions. So yeah, let's dive right in. We're just swimming in data, right? Every single click you make, every purchase, every little online interaction, it all creates a tiny piece of information. But here's the thing. All that data is basically just noise, unless you have a way to actually talk to it, to ask it questions and make sense of the answers. So the big question is, how do you do that? How do you have a conversation with data?
Well, the answer is SQL. That stands for Structured Query Language. Honestly, the best way to think about it is like a universal translator, but for databases. It's the standard language we use to store data, manage it, and, this is the really important part, get it back out again. It's what turns all that raw, messy information into actual, useful insight.
Okay, so to make all of this super clear and easy to grasp, we're going to stick to one simple analogy for this whole explainer. I want you to imagine we're building a massive library completely from scratch. We're going to build it, stock it with books, and run the whole thing. Trust me, this idea is going to make every single piece of SQL just click.
So, first things first, we have to put on our architect's hat. I mean, you can't have a library without a building, right? You need walls, you need rooms, you need shelves. In the world of SQL, this phase is handled by something called Data Definition Language, or DDL for short. It's all about creating the fundamental structure, literally the blueprints for our database.
Now, as the architect, you have some incredibly powerful and simple tools. The create command, that's your construction crew. It builds the whole library, the whole database, right from the ground up. But on the flip side, you've got the drop command. And that, well, that's the demolition crew. It completely and permanently tears the whole thing down. So yeah, you got to be careful with that one.
But really, the most important command you'll use as an architect is create table. Think about it. A library building is useless without shelves for the books. Same thing with a database. It's useless without tables to hold the data. Each table is basically a dedicated shelving unit, specifically designed to hold one type of information. You know, one for books, one for library members, and so on.
So let's look at a real blueprint. Imagine we're creating a shelf, or a table, called product. When we build this, we have to define each column very specifically. We give it a name, like PID for product ID. We tell it what kind of data it will hold, its data type, like int, which just means an integer, a whole number. And this is key. We can add rules, what are called constraints. For instance, we can say that every single PID has to be unique, and that the price must always be greater than 0. Laying down these rules from the start is how we make sure our data stays clean and organized.
All right, the building is up, the shelves are ready to go, so it's time to take off that architect's hard hat and put on a new one. Now, we're the librarian. Our job is no longer about the structure, it's about the books themselves. We're going to use something called Data Manipulation Language, or DML, to actually manage the collection. So let's get those shelves stocked.
And librarians' day-to-day work really comes down to 3 main jobs. First, you insert. This is how you add a new book, or in database terms, a new row of data, onto a shelf. Then you update. This is for when you need to change something about a book that's already there, like fixing a typo in the title. And finally, you delete. That's for when you need to take a book off the shelf for good. Let's see what that actually looks like. This command here, insert, is basically saying to the database, hey, go to the product table and get ready to add a new row. Then we just give it the values in the exact same order as our blueprint. The product ID is 1, the name is Old Monk, the price is 300, and the quantity is 1. And boom, just like that, our first book is officially on the shelf. Okay, so we've built the library, we've stocked the shelves. Now we get to the part of SQL that you will use probably 90% of the time. It's time for our final hat. We're the researcher. Our whole job now is just to find information. And we do this using data query language, or DQL, which really is all about one single, incredibly powerful command, select. Almost every single question you ask in SQL follows this same basic structure. It's like a formula. First, you select the pieces of information you want to see.
This is like telling the librarian, hey, I want to see the title and the author. Next, you have to tell them from which shelf to look on, from the fiction section. And finally, you can add a where clause to narrow it down. But I only want books written after 1950. See? Select from where.
So let's build a real one. Let's say we have a table called EMPS that lists all our employees. If we write this query, we're asking a pretty simple question. We're saying select the FNAME column and the SAL column from the EMPS table. What you get back is just a big list of every single employee's first name and their salary. But, I mean, a giant list of everybody isn't always super helpful, right? We need to get more specific. So we just add our where clause. By tacking on where job equals waiter, our question just got a whole lot smarter. Now we're asking, show me the first name and salary, but only for the employees whose job title is waiter. And we can get even more precise. We can use the word and to just stack conditions on top of each other. So now the query is asking for employees who are waiters and who also have a salary greater than $45,000. It's pretty amazing how quickly you can go from a huge pile of data to the one specific piece of information you're looking for.
But look, finding the right data is really only half the battle. A good researcher doesn't just dump a random stack of books on their desk. No, they organize their findings to make sense of them. And SQL has some awesome tools to help us summarize and sort the answers we get back, which makes them way, way more useful.
There are two main commands for this. The first is group by. This is all about summarizing. It takes a bunch of individual rows and collapses them into neat little groups. So instead of looking at every employee, you can ask, hey, how many employees are there for each job role? It gives you the big picture. Then you have order by. That one's simpler. It doesn't summarize anything, it just sorts the list you get back. List the employees from the highest salary to the lowest.
And this bar chart, this is a perfect example of what group by does. A query that says basically, count the employees and group them by their job would give you this exact result. So instead of a long, boring list of every single person, you get this one clean, easy-to-read summary. We've got 4 waiters, 3 chefs, and 2 managers. It instantly turns a table of raw data into a story. So let's just take a step back and look at what we did. We've actually worn 3 completely different hats on this journey. First, we were the architect, using DDL to design the whole structure. Then we became the librarian, using DML to manage all the books in the collection. And finally, we put on our researcher hat, using DQL to ask smart questions and find the exact answers we needed. And that, right there, is the true power of SQL.